don't know if you ever saw that.
All right, ladies and gentlemen, how's everybody doing today?
Great.
All right, good to hear. My name is Chase. I'll be your host for the duration while we're here inside of Mission Control. Now, before we get started today, I just have to make a quick safety announcement. If we have to evacuate the building today for any given reason whatsoever, our #1 evacuation route is going to be back down that exact same way you just came up, down the stairs, right back out to the train. Now, if that way is blocked, we do have a secondary evacuation route on the top right-hand side of the room, kind of behind you guys a little bit. There's a glowing exit sign hanging from the ceiling, so you can't miss it once you get up there. Same thing for that one, just down the stairs, right back out to the train. Now, ladies and gentlemen, I'd like to welcome you to our Mission Control Center. Now, in this center, we have 3 different control rooms that we've used over the years. And the TV screens up on the top left and right-hand side, you can see the International Space Station Control Room. That is our newest control room. We use that one 24/7, 365. There's always someone on the space station, so we always have to have someone that's manning that center right there. Always someone to communicate with the astronauts, so they're never alone up in space. We also have our historic mission control room that we used back in the 1960s. That one is located 1 floor above us. It's called the brown flight control room. That's the technical name that they have for that room. And then this one that we're in today is called the white flight control room, or the white thick room. What you would more commonly know this room as, though, is the Space Shuttle Mission Control Room. That's what it was mainly used for. From 1995 until last year, this is the room that controlled each and every one of our space shuttle missions. So this is the real deal where it really happened at, a very special place to be. Now, I'm going to take you on a little tour around the room today and tell you about the 2 most important positions that we have here at Mission Control. I'm going to start you off with the #1 job today, and you got to kind of bear with me a little bit because the consoles don't have the plaques on top of them anymore. As you can see, this room is kind of looking barren right now. It's not in use for any missions because we don't have any missions or any spacecraft to launch right now. So mainly this was being used for training new personnel, getting them used to what it's going to be like to sit at the consoles and use the technology, also working on the communication systems in between to and from the consoles so they can communicate with each other. But right now they're in the process of actually upgrading this room. They're going to rip all these consoles that you see right here out, and they're going to put some new ones in for our next generation program. It's called Orion. I'm going to talk to you guys a little bit about that at the end of the presentation, so just kind of bear with me jumping from console to console. 2 rows directly behind me, you're going to see that console. It's got 2 chairs in front of it. It says, or doesn't say, flight director is what I'm talking about. 2 rows behind me right there. Now, the flight director is the boss of all bosses inside of this room. There is no higher authority whatsoever than a flight director here in Mission Control. No one can go above them and no one can overrule them. And when I say that, I mean no one on the face of this earth can overrule anything that a flight director says. And not even if the President of the United States of America walked into this room during a mission, the flight director actually has the power and the authority to overrule the President of the United States of America. That is how much power that they have. But if we have any Spider-Man fans, you know that with all that power comes the responsibility. As a flight director, what your job is to make every single decision, no matter what. You have to say yes or no. You're the final one to say yes or no to everything. So you can imagine how stressful that is, trying to make the yes or no call for every decision. Because what if something goes wrong? Who are they going to turn to? The flight director, right there. They do every single call, no matter what. They are held accountable for everything inside of this room. Even if it's something that they can't control, even if it's an engine exploding, they are still held accountable right here. Now, when I say that, I don't mean that they come in and say the engine exploded because of you. That's not what they're going to do, of course, because they can't control that. That's a mechanical failure. But what the flight director has to do is he has to get all the data, everything that happened during the mission, find out what went wrong, why it went wrong, and how it's never going to happen again. And then he has to go before Congress and present that information. That's the responsibility he has to take on, or he or she has to take on nowadays. So it's a very, very stressful job, but it's also the most important job inside of it. Now, the same console that I was just talking about, 2 rows back, there's 2 different positions. The 2 chairs on the left-hand side are for flight director. The 2 chairs on the right-hand side are for Capcom. Capcom stands for Capsule Communicator, and it's a term that dates back to the days when we used capsules, back during our Mercury, Gemini, and Apollo programs. Then we switched to the space shuttle, which was not a capsule at all, but we kept the name over the years because we liked it. We'd used it for 30 plus years, so we didn't want to have to get rid of that name. Now, what Capcom does is it's the communication. It bridges the communication between Earth and space. That's the only position in the entire room, all these consoles, that can actually speak directly with the astronauts. Not even the flight director, the most important person in the room. They do not even have a direct link. If they want to talk to the flight director, or the astronauts that is, they have to go through Capcom, just like everybody else. But that's why it's located just to the right-hand side of the flight director. So if they want to talk to him, all they have to do is turn to their right-hand side, and there the astronauts are, right there. Now, another special thing about Capcom is that we always have an astronaut that's manning that position at all times. No matter what, a fellow astronaut back down here on Earth is communicating with the ones that are up in space. And the reason for this is because they use a special language. They're still speaking English. It's not a different language. It just sounds like a different language. They use a lot of acronyms and code words. They shorten everything up to make it more quick and more precise. Actually, a perfect example, if you look at the top right-hand corner over there, you see all those orange numbers that are kind of brightly lit up there? And actually, you can see crew sleep right there, 4 hours, 29 minutes, 41 seconds. That means the crew is going to be going to sleep on the space station in 4 hours. That's live happening right now. Now, the bottom numbers that you see where it says ISS W171 SKLOS, or SKLOS, if an astronaut read that, that may be 2 to 3 sentences long. Just those amount of words right there. You can see on the top right-hand corner right there. But if they read it, they would elongate it out and make it exactly what it's supposed to say. And it could be 2 to 3 sentences long, just that little bit of information right there. So that's what it does for us. It just gets the information up to the space station faster, so we can have more time to use it. And, you know, instead of reading page by page by page, they can read just paragraphs. And so that way they have that extra time to actually work on the problem, fix the experiment, do whatever needs to be done up in space. So this language is just there to ensure that we are never wasting time, and we always have the best amount of time to work up there, basically. Now, the future of the program, ladies and gentlemen, I definitely want to touch on that for you guys today, because that seems to be the biggest question on everybody's mind. Where are we going, and what are we doing next here at NASA? And over the past year and a half or so, I can understand why everyone's been so confused, because even here at NASA, the employees that are here, they did not even know exactly what was going on. We had a bunch of different ideas that we could have chosen from, but we didn't actually choose an idea, call it a program, set a date for it, and start pursuing that goal. We have officially done that at this point in time, though. It's called the Orion Space Program, and that's going to be giving us the Orion capsule as well. That's going to be the spacecraft that we get from it. So we're going to go back to capsule technology, just like we did in the 1960s during the Apollo space program. Now, some people ask, I actually got the question yesterday, why are we going back to capsules? You know, why not do something like the space shuttle? You know, we have this new technology. Why are we backtracking and going to something that we used in the 60s? And the space shuttle is only operational about 500 miles away from the surface of the Earth. If it gets further than 500 miles, when it returns, it's coming back at such a high speed that it would burn up on re-entry. It would basically disintegrate, even with heat shields. It's just because of the shape of the shuttle. The shuttle has a 25-foot wingspan, so if you're traveling at 25,000 miles an hour and you hit the Earth's atmosphere with something that has that kind of a wingspan and that shape, it's just going to rip right off, basically. The force of it is just going to rip right off. But with the capsule, we know that that can return from deep spaceflight because we've done it before with the Apollo program. So we know that that capsule technology is capable of getting us further out there than we've ever gone before. And that's what we want to do. That's what we want to get back to here at NASA, is exploring our solar system, going where we've never been before, and finding out more about space than we ever have. The biggest goal that we have for Orion, what we mainly want to accomplish, is Mars, the red planet of Mars. That's going to be the next destination for us that we're going to set down human beings on the planet of. And that mission's not going to happen until about 2035, 2040 sometime. So it'll be another 20 years before that gets underway. And the reason that it's taking so long is the distance that we have to travel and also the obstacles we have to overcome. The moon is 3 days away, 240,000 miles in distance. Mars is 6 months away, 35 million miles, at the closest that it ever is to the Earth. So you're talking about 6 months there, 6 months back. That's 1 full year just for travel. And then you're going to stay on planet as well for as little as 45 days or as long as a year. So that could be a 2-year-long mission, ladies and gentlemen. Now, I would recommend to you guys, when you get back to Space Center Houston, definitely check out our other tour. It's called the Red Tour. It's going to take you to the Space Vehicle Mock-Up Training Facility. And at that facility, you'll actually be able to see 2 mock-ups of the Orion capsule, full size, exactly how they're going to look. What you can compare it to, though, is the Apollo capsule. So at your next stop at Rocket Park, at the very tip of the rocket, you're going to see a rusted-looking, kind of discolored piece, smallest part of the rocket as well. That's where the astronauts sit, up at the very top of it. And the Orion capsule is just going to be a little bit larger than the Apollo, because we're going to put 1 more astronaut in there. It's going to seat 4 astronauts, whereas Apollo only sat 3. So when you see that capsule at Rocket Park, I want you to ask yourselves, how are 4 astronauts going to survive in a spacecraft that is that small for 2 years at a time? How are they going to live? How are they going to eat, sleep, use the restroom, change their clothes? The food supply itself, are we going to grow the food on the spacecraft, or are we going to pack an abundant supply of food to make sure that they have enough to eat for the entire duration of the trip? Those are the challenges that we're trying to overcome. And also the microgravity environment. We can't feel it right now because our bodies are so used to it, but we have 1 G of gravity pushing against us right here and right now as I'm speaking to you guys. It's holding us to the earth, and it's also holding our bodies together as well. So when you go into space and that 1 G of gravity gets taken off of your body, you have microgravity in space. It's just barely, you can barely feel it. Some people say 0 G, that's technically not a proper term. There is gravity in space always, but it's just very, very minuscule. So they call it microgravity because your body can barely feel it. So when that happens, your body's going to start to change. It doesn't have that gravity holding it together anymore. So your muscles are going to start to deteriorate, and your bones are going to get smaller, and they're also going to get further apart. They're going to start spacing out a little bit because they have some room to move, basically. When you're down here on Earth, we have large back muscles and large neck muscles to keep our back upright and straight, and also to keep our head from bobbling back and forth because of our gravity here. When you go into space, though, you don't need those muscles anymore because you're floating. You're in a microgravity environment, so you don't have that gravity weighing down on you. So your head and your back are just floating. You don't need to do anything to keep upright, basically. So that's why your muscles start to deteriorate, because we're not using them. So the way that we stop that is we do use them. We exercise them. That's the way to kind of keep them in working condition. Same way we would do it down here on Earth.